I already have information. You can go and look at it, okay, each form, and see if they are correct or not. If it's not, let me know. But I want to do this one together with us for the rest of the evening. This table here, this sales order details here, kind of similar to one in the notes. If you think about this table here, you can actually break this down into many tables, and I don't think we'll finish it, but we'll see how far we can get. I can't zoom this in. Okay, so I have this sales order here. It's just 3 orders. We can say the first normal form, we have the primary key, so that passed, right? The second rule says you cannot have multi-value columns. Okay, so this is okay. This is okay because it's not multi-value. I could, if I have like Bruce Wayne, comma, Jill Lane or something, then that's multi-value, right? So that's fine for this column. What about this one here? Yeah, it is multiple, right? Or you can, well, actually, yeah, it is. Well, you could break it down into 4 columns, or 3 columns. So you need to break that out. Phone numbers, also multiple. So you can see that I failed already, right? So anyway, so that's good. You need to break that out. This out. This is okay. This is okay. The address, again, same thing as over here. So you can break that out. This one also failed because one has 2 numbers here, same thing. And then the product. That also have multiple. So those columns fail. So what should we do here? So we can add columns, additional columns for the address, the street name, the city, the zip, and the state. Or you can say, we can take this employee information out. All these are about the employee here. These columns here, right? And then we can take that whole thing out and make its own separate table. Okay? So if I do that, if I say take the whole row out, or columns out, and if I were to, it's kind of hard to do here, but so what should go in its place? Let's do it again. If I take these out and put it over here, somewhere over here. Okay, so
Replace it with an employee ID.
Yeah, right. So we can replace these with the employee ID. Let me add that additional column here. Insert just one column to the left of this. So here we need to put an employee ID here, and so we can add another column employee in here. And this could take 1, 2, and 3, and 4, however you want to choose it to use it, right? It could be numbers, it could be something else, so it's up to you. And then in here, we'll make this as the foreign key. And we'll pick this the FK here. And then this could be for Bruce, this is Peter, and this is Clark. Okay? So now this one is unique. Well, it's all about the employee, so that one is good. And then here we have this address here, right? It still fails that first normal form. So we have to break this out and simply the phone number into their own separate columns. So let me just, cut this, put over here. Let's see. Okay, so that means that I could break this into the address. They have the city, and then state and zip, and so on, right? And then state, zip. And the phone number, the same thing. You can break this into 2 columns, just so you meet the rule. You can say here phone 1 and then phone 2, right? And I'm not gonna put data over, but that's what you get. And this is by itself, so you're good. So this table here now meets the first normal form, right? It has a primary key. This will be the PK. Well, actually here you can leave it as is, or just to make it better, you can break this into first name and last name. Okay. Usually that's the preferred way, but I mean it doesn't violate the first rule. It's just that it looks better that way. It's also easier if you want to sort and search data. It's better to have its own column. So you can break that into first name and last name here, and it's all good, right? And so the first normal form is fine. How about this table over here? Once you take that out, you have to consider this one too. So again, we have the same stuff. We have the customer information here. Okay, so I can do the same thing, right? You take all this customer information and you take that out and put over here on the far side in here. We'll put the customer table over here. I have the customer ID already, that's good. And then on the original table, I will leave the customer table column as it was before. We'll make this the foreign key, right? So again, it's linked to this customer because one customer. So if you look at the employee table here, why did I put this as foreign key and this is the primary key and not the other way around? Yeah, the same thing here. Why do you put this as foreign key and this is the primary key? So, yeah. Oh, right.
Your sales order, and your sales table, the primary key is your sales order. And that's all the entries in there is a part about sales, and then you're referencing customers, or you're referencing the employee numbers.
Yes. Yeah.
Whenever you're referencing those are foreign keys.
Yeah, right. That is correct. But why? I mean, how do you know that? Why did you decide that the foreign key is here and not over here? Why don't I put the sales as the foreign key over here? You know what I mean?
Because the unique ID in the sales order details table is the sales number. There's only one sales number that's going to be 111, whereas employee ID number 1 can have multiple sales in that same table.
Yeah, I think you got the
When
idea.
you look at the employee table, there's only one employee number 1, so that is a unique value there.
Mm-hmm. Right. So, right, you are absolutely right. So you think about relationships, okay, business models here. So you think about this way. I have a sales order. I have an employee. Now, so as an employee, you can have many sales orders, okay? So I can sell one car, this order for one customer. I can sell the same customer can sell another car with the order number 114 to the same customer again, or a different customer, doesn't matter. So if you look at this, if one employee has many orders. So that's why the 1 is always the primary key. The many side is the foreign key. Okay? It doesn't make sense to go if you go the other way around. A sale order can have many employees. So in other words, I guess unless you allow it, right? But usually you have one order is sold to one person, by one person. Okay? Unless you have a dealership that allows, 2 or 3 people here can sell to one individual and you co-share the pay, I guess. If that's okay, then we have a many to many relationship. Okay? But in this example, it will be like a 1 to many. Same thing here, right? A customer can be a client. Well, yeah, a customer has one order or have many orders, right? I mean, I can buy one car from this dealer, or I can buy a lot of cars from this dealer in next, month or next year. I can come back and buy it again. But one order here is usually very unique to only one customer. Okay, so again, you have the 1 to many relationships here. So again, so that's why we put the foreign key here. And so usually, if you think about this, that's how it is. Or the easiest way is basically every time you take out some data out of this big table, these are usually the foreign keys. Okay, you end up as being the foreign key because you take something out of it and you can link it back to that as the foreign key. And sometimes you don't have it at all because you might remove this table completely and you build a different table out of that. So you have to also consider that too. But usually when you take it out from this big table, you have a foreign key in there. Okay. So now this customer table here is not first normal form because we have the addresses and so on, the phone too. So we can break this out. It will look something just like this one here. Okay, it's the same rule. Once you do that, then it qualifies, it meets the first normal form. And then this one here, we still have things to do. So we have the products information here, right? So you can break it down to each columns. Maybe you have the Jeep. It's like a make, right? Make, model, VIN number, and then the descriptions or the features here. So again, you could take this whole thing out and put it into its own table, and then here you put the product key, right? ID, and then you make that the foreign key. And here just put, maybe you can use the VIN number as the key. Okay, so over here, where you have this table of products, this could be the product ID, and then you have the make, model, and then we have the features, and then maybe the cost as well, the cost of the car. Okay, so that can also be taken out and added to the product table. So you put Jeep and then a Wrangler. Sorry, it's the VIN number. This number here, this will be the VIN number. You can use that as the ID, and then we have to make, will be Jeep Wrangler, and then the description we have 4-door heated seats. So here we have another problem. The feature is not normalized, right? It fails that second rule. So you have to break it down to a separate column. Again, so you can take this out into another table. You can see how fun this gets, right? So put a feature over here. Let's put it over here. And I have here a feature ID. Could be 1. Here will be just 4-door. 2 will be the heated seats. Right, you get the idea, right? And you can see all the other cars has it too, right? You have the navigation, so 3 could be for navigation, and so on. So each has their own data. And then since it's the feature ID we took up from here, then I have the feature ID here as the foreign key. And it will be linked to 1, to 2, and 3, and so on. Okay, so you got the idea. So now that qualifies as first normal form. The other one is completely normal form. This is actually already in third normal form. We actually, since we have anytime we have like a really short columns like this, 1 or 2 or 3 columns, usually that can be easily converted to the third normal form. Okay, even the 5th or 6th normal form by default, because it's just so simple. Okay, so this is good. This is good.
The features have me confused.
The feature?
Yeah. Because what if product ID and that VIN number
Oh,
has multiple features?
Oh yeah, you're right.
Then what?
So would you have to go feature 1, feature 2?
Mm-hmm. Yep, you're right. So
Maybe you create a table of packages, right? Feature packages or something like that.
yeah, yeah, okay. So great. I'm glad you asked that because I didn't catch this. So
It's gotta be, the features have to be in different rows.
yeah,
Yeah, so,
Yeah.
so feature ID number 1 has this door package and this seat package
Mhm.
and something like that.
yes,
Yeah.
perfect.
I don't know what
Package is
that-
its own ID.
Yeah.
And I'll let you get a package, feature package ID for
Yeah.
strangers.
Yeah. So this is
Like that.
this is an example of a. So if you, well, okay, let's look about these two tables here. Let's look at the product and the features. So a car, the Wrangler, can a car have more than one features? You can't, right? Can one feature be applied to more than one car? Yes, so we have a many-to relationship here. Okay, so now this brought up to that example. So to make this work, because if you don't do this, I will have to list this X number of times just to show a different feature for this ID. I could list this again, for example. I might do that here, and then show feature 2. And now if I do this, this is no longer unique. So I have to have another ID here to track each individual car here, which makes a lot of problem, right? So what you have here is what's called a many-to-many relationship, and I'm glad you caught that, Julie. So thank you. So now what you do is you have to have a junction table between this and the product table to make this work. Okay. So let me copy this, and we'll move it over here so I have more space. Let's put it over here. Okay, so I have the feature table here, and let me just put that here. We have the product. Okay, this is a so when you build a many-to-many relationship, you have to have a junction table. So here I'm going to move this a little bit on the side over here. Okay, I'm going to have another table in here, which will have the product ID, also have related to the feature ID. Okay, so this is the junction table that can link the two. And this is what's needed if you want to build a many-to-many relationship. So now I can put the product key in here for 1. The feature would be 1. 1 has also heated seat 2. And maybe if the car 1 has also has navigation, right? So this will be the foreign. Yeah, you're right. So the VIN number. Sorry. So I'll just put that here. Yeah, let me make these numbers much bigger. Let's go to 11. Okay, so right, you have the VIN number. And let me just increase it a little bit, you can see. Okay, so this ID here is the foreign key for this table here. And this is the foreign key from this table over here. Okay? So if I say, give me the car that has a product ID of VIN number this, that has, then join, right? Join this with this to have the, you have a matching of product ID in this table, and join this table over here with the matching key of this, right? So if you look at this, you see that now this VIN number here belongs to this car Jeep, and it has 3 features. Okay, and all these 3 features here describe this single car. But this column here, this VIN number, will reference this single car in this table here. Okay, so this is a many-to-many relationship. But you still have to make sure that this is still normalized. Because we know we have the foreign key. What about the primary key? Right? So you could have something like this. You could build something like here, I don't know, car feature ID as the primary key, 1, 2, 3, just to make sure they're unique, right? So this could be the primary key. You could do that if you want.
Now the cost could be variable depending on the features, right?
Mm-hmm. So you add a third column. If you want to do that, you can add additional information there as well. You can put the the cost based on each feature. So you can have a cost column here, and then the door could be like whatever, $10 or $100, whatever it is, right, for each feature. Assume that you don't have it, then you can make this 2 as your composite key because they are unique, right? They'll always be unique. In this case, it's the last digit makes it unique because you're not going to have, the same car has like 1 and a 2 here, right? You don't have that. Okay, it's always going to be just 1 based on the foreign key, so it's unique. So therefore, you can also make this as your PK. And then this is PK, so you have a compound primary key. And they're also foreign keys, okay, to a different table.
So for the homework, are we building these out in a spreadsheet like this, or are we actually creating the tables in the
You will do both. Okay, you can draw it out by hand if you want, that's okay, for the design part. But also, once you do that, then I also want you to go into the study and build a table, and then the foreign keys, and then also generate the ERD. Okay, so
And in
the diagram.
1, 2, 3 order to show you the evolution.
Mm. Yeah.
The third normal form.
Yes. So on the first normal form, if you want to break out into different tables, as long as they meet that first normal form, leave it at that. Okay, don't paste a third normal form in there. In this case, it's okay because if you take this out, for example, then that's already part of it, then that's fine. But I should see your table in the first normal form, like we saw up here. So this is the first normal form. So this is completely fine. Okay. Okay, so I hope that makes a lot of sense here. So every time we have something like this, right, you always want to think, can a car have that many features? Can this feature be applied to many cars? If that's true, then you need a junction table. And the junction table always take the primary key from one table as a foreign key, and then the other foreign key will be from the primary key of the other table. Okay, and you combine this together, and then you have a many-to-many relationship table. Okay, so we got that. And then we have the product ID, so this would be like the VIN number, right, for each of these. For each of these cars. And they'll be unique because each car has a unique ID, and so on. And then the date sold will be fine, part of that. And we can combine this together. And so now this table is it's good. It meets the first normal form. And so I'll do this, and all of these are, so we're good.
We're just kind of doing this, and the reason I ask is I'm trying to make sense of it. A VIN number actually has most of that information in it.
This information?
Yeah.
Right.
So a lot of the VIN number
Right.
shows a lot of that information.
So the VIN number, right, so that's what you put in the product's information here. The VIN number tells you that it's a Jeep, it's a Wrangler, has these features for this car.
Well, what I mean is the number itself.
Mm-hmm.
The VIN number on your car,
Mm-hmm.
if you go out there and take it down and you look it up,
Yeah.
it will give you a list of quite a bit of information of your features, the color, when it was made, engine size. It's
Right.
all encoded in that number.
Right. That's what we're showing here. How do you see that information?
Hmm?
How do you see that information? It's a Jeep, it's red, it's built in 1945, for example. How do you know that?
In the VIN number.
So if I just give you this VIN number, can you tell me it's a Jeep?
I don't know if I can tell you the model
take that
number.
VIN number and look it up in the table that.
Right, so you need
breaks
it.
down into all the pieces of what,
Right.
what it's telling.
So somewhere you
Still
need.
looking at a table
Mm-hmm.
in the great scheme of things.
Exactly. That's what you say. All these are dependent on the VIN number, right? Every column must depend on the primary key. That's exactly what you just said, right? So the Jeep, it's a Wrangler, has this feature, has this year, has this engine size, for example. All those are dependent on this Jeep VIN number here. But if you just give this VIN number, like you said, if you give this VIN number, you can look it up and you can tell exactly what the car is. That's exactly why you built this table, right? To make it very unique. But how do you see those is the actual data. We don't see that. So you have to put in the data here so we can get those data out. But your point it's made a pretty good point, and it's exactly why you have an entity that is to be unique about only one object. Okay, so for example, I wouldn't put something like a driver, for example, right? A driver wouldn't fit in this category because this Jeep can be driven by anybody. Okay, so.
Well, the DMV would have that related in another table as a registered driver. owner of
Yes.
that vehicle.
So if you have a driver,
Or
then
your ID with the driver's license number would be your unique ID
Mhm.
in another table as the driver.
yeah. So if you have a owner, that's different than a driver table, right?
Sure.
So one car can be owned by one owner, but can be driven by many drivers. So you have that relationship too. So when you build this table, expand it, you see that, oh, I have an ownership table. I also have a driver's table if you were to, let's say, work for a taxi company, right? So yes, you can see how you can break this out into a lot of tables, and they're related in those situations. And then above all this is just basically you are trying to solve some business problems. That's all about building databases. Really, you build database based on business problems, and you'll see that if you go into become a DBA, for example, you go into deeper in database design. That's exactly what you do. You have to come up with a list of business issues and how do you solve it, and then from there on, build your database based on those to meet those business needs.